Okay, now we'll talk about indefinite integrals. And the symbol we're going to use for antiderivative is a squiggly line, f of t, dt. And if it's indefinite when there's no upper or lower limits on the integral. So just note this is a definite integral because it has an upper and lower limit on the integral. So this is a definite integral because you have the limit from a to b, and it's equal to a number. It equals a number. This indefinite integral is a function. So since it's the antiderivative, and when we take the derivative of capital F, we get the integrand. This is called the integrand. And this is called an indefinite integral, and that's not equal to a number, it's equal to a function. It depends on your variable. Since f is an antiderivative of f. Okay, so some of the properties we need to talk about. The antiderivative of, actually that's 1, is x plus constant. If I have a constant with the function, I can bring the constant out in front, then integrate it. If I have two functions being added or subtracted, I can separate them out. And the exponent rule, where I just add 1 to the exponent and divide by the exponent, as long as n doesn't equal -1, otherwise you have 0 in your denominator. And then the trig functions. Since the derivative of sine x is cosine x, and the derivative of tangent is secant squared, so the antiderivative of secant squared is tangent x. Since tangent x prime is secant squared x, and so with the other trig functions, since the derivative of secant is secant tangent, the antiderivative of secant tangent is secant, and cosecant cotangent is minus cosecant. Okay, so those are just some properties that you need to know. And then let's go back and talk about a real-life example. We know velocity, or rate of change of distance over time, is s prime of t. S of t is position or distance. Well, let's say it's distance. Distance traveled in time t. So the antiderivative, a to b of velocity, is the definite. Let's do definite integrals. We're doing definite integrals here. So that's s of b minus s of a. So that's just a change in distance from time a to time b, which really is just a displacement. How far do we go from the starting position to where we ended? Also, v is the antiderivative of acceleration. Okay, so if v is positive, then the particle's moving, or whatever you have is moving to the right. If you're moving on a straight line, so we're going this way, and if it's less than 0, well, equal to 0, it doesn't move. Particle moves to the left. So again, we're talking about a particle moving left and right on a straight line. And the absolute value velocity is the speed of the particle. So the total distance that this particle has traveled is the definite integral of the absolute value of the velocity. So suppose your particle does something like this on a straight line. So it goes from A to C to D to B. So it starts, say it starts at A, it's going to the right, then it goes to the left, and then it goes to the right. So it goes right, left, right. So this is going to be the integral from A to C of velocity is positive here, then in there it's negative, and then here it's positive again. So we had to add a negative when it's going to the left to get the displacement. Say and let's see. Okay, it's negative from C to D. This is C. And then from D to B, it's positive. It goes to the right. So that's going to give you the total distance, not just the displacement. So in another real-life example would be when you integrate the rate, change in a, which is, the rate is a change in a function, whatever that function represents, over the change in time. It's kind of like the change in time cancels out, and that's going to give you the change in the function from A to B. Okay, also, to check your answers is really easy. You should always check your answers. If you're taking an indefinite integral and you get another function out of it, to check, take the derivative of f, and it should equal your integrand. which is your little f. So f prime, the derivative of your answer should equal your inside function. And if it doesn't, you either took the derivative wrong or you took the integral wrong. Okay.